Okay, so welcome to our special webinar about QFTest 11, AI Agents in Action. New efficiency with QFTest 11 through AI and MCP. So this is kind of a follow-up to our last special webinar about AI with all the new things that we introduced in QFTest 11. My name is Max Melzer. I'm a software developer at QFS, and my co-moderator is Daniel Ried, who will be giving you the presentation, and I will keep an eye on the chat and on your questions and try to answer everything that comes up.
All right.
Yeah, we are both developers who work on all of these cool features that we are going to show you here today. So we are proud and happy to begin. Daniel.
Thank you, Max. So it's my job to tell you about our new exciting features in QFTest 11, especially our AI features, but I will be touching on some minor other things too. And this is the agenda for today's webinar. I will talk about basic concepts of AI in QFTest. Then I will show you how to connect your AI models. And then I'll go over the different features we have, the AI test data generation, the generation of tests with AI, the AI instruction node, and last but not least, the QFTest MCP server. First, some concepts about AI and QFTest. In our thinking, we split it in two areas. We have AI in QFTest and AI with QFTest. So AI in QFTest are all the features you can use in QFTest with AI. So we have test data generation, test suite generation, the AI instruction node, and an AI scripting module. And with all this, we have one approach, our bring your own model approach, which means we do not provide any LLM model, but we allow you to connect basically anything you're able to connect. So you have the full control over your data, and you can easily adjust what you're using, for example, to save tokens by using cheaper models. And yes, you are absolutely free which models you use. And also, we have the area of AI with QFTest, which means how can AI use QFTest? So we can, our QFTest will provide an MCP server, which provides certain tools. So the AI can use QFTest and its capabilities for component recognition or for UI, user interaction with any program, to control basically any third-party application that QFTest can control. So you can, with QFTest as a middleman, let your AI control any Swing application, web application, mobile applications, whatever you name it, you can do this. And you're not limited to a set of MCP tools we provide from the get-go. You always have the option to create your own MCP tools. This we call the MCP toolkit. But yes, to get it all started, we first have to connect our AI models. And for this, I'm going to switch to my QFTest. I'm using QFTest 11.0.1, so the newest version. So there might be some slight differences if you're on 11.0, but I will make sure to mention them. So first, we need to get everything up and running, and we need to configure some LLM configurations or AI configurations. To do this, we simply go in the options to artificial intelligence and have a look at this table where we can define our models. And you can, of course, connect via an URL or an API and an API key, any LLM. For this demonstration, I will be using a new feature with QFTest 11. I'll be using a command line tool, and I will simply do the configuration now. I want to use Claude because that's the AI assistants we use at work. So I'm simply choosing the Claude Code CLI. I'm gonna name it Claude to make sure I know what I'm using. And the neat thing with 11.01 is that now my configuration is basically complete, because we try to find Claude, the path to the Claude application ourselves, and it usually works. But if you're uncertain if we can find it with our program, or if you're using an older version, you can simply find out where your Claude installation is. In my case, it's right here. And all you have to do is copy the path to your Claude binary in here, and it will work. So there's no API key needed for CLI models. And also, we try to use very sensible default models. So you can leave this empty. But for all the test runs, I used Claude Sonnet 5, and I'm not going to change anything for this demonstration, for this webinar. So another thing to mention is that the application that's on top is the default application. So on multiple occasions, you can say which configuration should be used. And if you don't specify anything, it will default to the configuration on top. And to avoid any problems, because this is obviously just a demonstration, API key and URL, I'm gonna make Claude the default application for today. Okay, well, that's basically it. Now I've defined my LLM, and to test if it works, I'm gonna try to use it. And to use it, I'm gonna use one of our neat little new AI features, the automatic generation of test data. So what I have here is a data table you can use in a data driver for your tests. You've probably seen this before if you work with QFTest. And by simply defining columns like name, address, or age, you can have QFTest generate table data. So let's do this. You can enter a small prompt here, like generate 5 entries. And choose your AI model in this dropdown. And once you do, we have to wait a little bit. And then we will have some neat little test data generated by our AI. And as you can see, these are 5 random persons the AI just thought of. And now you have data to use in your tests. Let's have a look at how this works. Every time you use an AI feature in QFTest, we generate a run log. So you can always see what happened. And generating table data is no different. So the first thing is the system prompt. As you saw, I entered my user prompt, but to make sure the data that's generated is in the correct format and other certain things are done, we have a system prompt. And the system prompt is defined in a very specific place I'm going to show soon. Anyway, this system prompt is combined with my instructions, as you can see here. And these are sent to my Claude model. And the Claude model is responding with the data, and this data is entered into the table. The prompt is very interesting. I'm gonna show you the prompt because there is a chance to modify it to your liking. So what you have to do is you can find the node in the test suite, and we're gonna enter the next big topic of our next big thing of our new features, the QFS AI QFT. This is sort of a standard library. You can compare it to our QFS QFT, but instead of providing procedures that you can use, it basically provides procedures and prompts that an AI can use. And it can be modified if you so like, but yeah, I'm going to show you how to modify it the best soon. So as you can see, all the AI did is it went into this package, which is annotated by with this annotation, MCP prompts, and it had a look at the generate table data procedure. It brought some parameter with it. It got a system prompt, and it combined it with the parameters and my instructions to create a prompt for the AI, and the AI used this to generate table data. So what I can, of course, do is simply change anything about this prompt here. And if I save my QFS AI QFT, in the future, it will take this modified prompt. But there's a better way. For this, I'll quickly have a look at the options to demonstrate. If you go at this tab, the MCP and agent skills, you can see here is our QFS AI QFT, our standard library, but above there are other libraries. In this case, there's a user AI QFT. This is a custom test suite, which is meant to override the QFS AI QFT, or it can override, say it like this. And if you change anything in the user AI QFT, it will also be considered by our AI features, by our AI agents. So what I'm going to do is I'm going to open this user AI via the bookmarks to the AI user library. And here we have an example package for prompts. Yeah, it's already annotated with prompts. So what I'm going to do is I'm going to take this procedure, simply put it in here. And now I'm going to modify it. What I'm going to do is I'm going to tell it, generate the data in French, if possible. So this should be very visible once we use it. Okay, I'm going to save. And now we simply do the same thing again and have a look at the protocol to see what happened. So this is my prompt, my user instructions. And I'm going to enter these, and hopefully the next entries will be looking more French. And indeed, we are in Lyon, we are in Marseille, or in Toulouse. So apparently it worked. Just to be sure, I'm going to have a look at the run log. And as you can see here, the prompt he took was from the user AI, not from the standard library, but from our custom library, because we have this entry right here. And we can also find the node on the test suite to jump to our user AI. This is a concept I'm going to touch upon later when I will show you the MCP server, so keep it in mind. So back to the presentation. You saw how I connected AI models, also command line tools. You saw how I used the AI data generation feature, including the prompt I overwrote. You saw the QFS AI library. And now I'm going to show you the test generation, the automatic test generation with AI. So this feature will generate a test draft. And it can also explore the application you provide to better find out what to test. So for this demonstration, I'm simply gonna use our old swing car configuration car configurator. It's not the well, the prettiest program, but what I want to show is that we can basically control, everything. So even these old Swing applications are controllable now with AI. So what I'm going to do is I'll simply go into a new test suite, so everything is separated. And now we have this button to generate and plan tests using agentic AI. For using this feature, it's important that, let me just jump to the options, the MCP server is enabled, because this feature is using MCP tools, for example, to check the UI, to manipulate the UI and other things. So I've enabled the MCP server, and now I can use the AI test suite template generator. This AI test suite template generator basically consists of two parts. First, my prompt. What do I want to test? Or what test should the AI create? Which I can simply enter here, or I can fill in from a file. So let me just enter it here. I want to generate a small test to test the functionality of the 5% discount button. And to make sure it doesn't get too extensive, I'm going to say stay in the vehicles tab and don't open any dialogues via the menu. This is what I'm going to do. Now I have different options. I can simply let him theorize and make a theoretical tests, which would happen if I choose this option. I can use the application I've already connected. So the car configurator is connected. So I can simply use this configuration. I could also use a dependency that starts this application. If I put it in this test suite, this entry will not be grayed out, and I can use this. Or I can use it as a sort of quick start wizard and simply provide the URL for a web application or for a Java file. I can provide the executable file path and simply start the application and then have the AI explore it. So if I press on this now, I'm hands off. I'm not doing anything. And now our AI agent, in my case Claude, is exploring this application, and especially the 5% discount button. So it will probably do some clicks like it did just now. It clicked on a model, and it will check final price and multiple other things. This might take a while because he's very thorough, and I don't have the time for it. So I'm simply going to stop it now. And of course, I've prepared it beforehand, so we don't have to wait for the AI agent. So this was the result that happened when I did this test the last time. As you can see, it created a test set. At the start, there are two comments. First, the test description, which shows my prompt, my user prompt, which was, of course, very short. And then it shows the generated test plan by the AI. So what did the AI found out about the application? What test scenario did it identify? And other things like what are success criteria, what are failure conditions? And all of this is put into a test plan, and this test plan is converted into, a test draft, I would say. And if you have a look here, this generated test is put into test case, test steps, and inside these test steps, we have AI instruction nodes. AI instruction nodes is the next topic I want to talk about. So basically, we have a very, very long tests right here. And this test is all realized via AI instruction nodes, at least until now. We are working to convert these AI instruction nodes to standard QF test nodes. But currently you have to do a little other manual thing to convert these, which I will show you soon. But anyway, as you can see, we have some very small test steps, and these tests, these AI instruction nodes I can execute, of course. And now our AI agent will use QF-test tools to hopefully complete whatever instruction I've given here. So in this case, it should click the first row of the table, which it did apparently. And yeah, let's have a small look at the protocol to see what he did. So as you can see, the A instruction node was executed. It got another system prompt for our AI instruction node. And then it tried to fulfill its instructions. And for this, it calls something called a tool. So these are MCP tools from our internal MCP server. First, you got a UI snapshot to have a look at the application, to discern the elements it needed. Then it called a click on the element. It got another snapshot to see if it worked. And then it logged a message, as you can see here, to log the result into the run log. So basically everything worked out in this case. But yeah, you already saw it took some time. So we recommend that you use this, you don't only use this A instruction node, but you try to use normal QF-test nodes wherever possible, because they, of course, save you money, they save you tokens, but they are also more reliable because they are deterministic. And yeah, to do this, for a start, you can simply enable the recording before you execute an A instruction nodes. And some of its user interactions will automatically be recorded and translated into QF-test events, like a mouse click or a text input. So as you saw, the AI did its click again. And this time I recorded it. So if I stop the recording now, I have the mouse click on the on the element. And now I can, in theory, remove this AI instruction node and go on and do this wherever possible. One more thing, you can, of course, always keep these AI instruction nodes. A thing I like to do is I use a test, I make a test, I put it in a try catch node. And if it fails to find some component for whatever reason, I have an AI instruction node as a backup, basically, which tries to use the LLM, use the agentic capabilities to execute the test anyway, even if my deterministic test failed. This is one thing you can do, of course. So the AI instruction node, as you saw, let's get back to the presentation. It executed a prompt and it used our QFS MCP tools. And these MCP tools are what basically the rest of this webinar is going to be about, because they are very, very important and very interesting. They are tools for our MCP server, and we have some predefined tools, as you saw, like the UI snapshot or the click. But you can also define your own MCP tools, which the AI can use. And yeah, one more thing I mentioned is that you can, for security reason, you can activate or deactivate them within our option dialog. I'm going to switch back to the option dialog to show it for 1 second. There you go. If you use them internally, like with our AI instruction node or other functions within QF-test, you have this column. And as I will show you, you can also use them from outside of QF-test. You don't have to use QFTest in an interactive mode. You can also use like a Claude Code CLI. And if you don't want certain tools to be exposed and to be usable, you can always disable them in this tab. Okay, but let's go back to our MCP tools because they are important. As you can see here, there was a call on our MCP tool, click on an element. So let's have a look at this procedure, find node in test suite. And as you can see, they are defined basically at the same place where our prompts were defined, but in a different annotated package. So when you look at the prompts, you saw there was this annotation to note that there are prompts inside this package. If you look at this package, you see we had this MCP tools annotation, which will show QFTest that the procedures within this are considered MCP tools, well, as long as they are not hidden via an underscore, at least. Yeah, so the click on any given position procedure tool, for example, was called before, and as you can see, it has a very extensive comment. That's because when we provide these MCP tools, the AI agent, of course, has to decide if it needs this tool, if it has to use it. And for this, it needs a description. And this is basically what you're doing here. You're giving a short description what this procedure is doing. You're telling the AI what parameters it's using. It needs to use this function. And if you want, you can give it a certain name. So usually, if you don't use this MCP name annotation, it will simply try to translate this procedure name into an AI compatible MCP tool name. So it will replace the white spaces with underscores and reduce the length of this procedure name to 64 characters, of course. But if you want to be sure, you can simply name it yourself. And to show you how to define your own MCP tools, I'm going to use a different application. We don't always want to show the car configurator. We want to show something else. So I've prepared something. Let me just start it. So what I prepared is a simple web application. It's a simple chessboard. There's no logic in this chessboard. The only thing you can do is like move your pieces, but well, you can move them anywhere. You can move twice, thrice, whatever, and there's no logic implemented basically. So if I want to interact with this chessboard, I have to bring my own logic. In my case, it's my mind. In our case, we're gonna try to let the AI play with this chessboard. So using only our default QFTest tools, it should already be possible for the AI to find this chessboard, to analyze it, and to make moves. So I'm just going to try it first. As you can see, my instructions are simply calculate and make one chess move. And for demonstration purposes, I also specifically said, please use the tools of our QFS MCP server. This is obviously not required, but usually the agentic AI should find this themselves. But yeah, just for this demonstration, I wanted to make sure. Yeah, and as you can see, this was a valid chess move. It looked somewhat good. It wasn't me, by the way, who did this. I should have shown my hands before. This was all our AI agent who was having a look at our chessboard, who was analyzing this, and who was making the moves. So if we have a look at the protocol, we can see it first tested the connection to our chessboard. It got a UI snapshot. It made a drag and drop operation. It made another snapshot to confirm that everything was done well, and then it logged a message. And the churn it did was from E2 to E4. Sadly, this message is in German for some reason, but yeah, it's an LLM. It probably thought I was German, which I am, but not for this demonstration. So as you can see, we used our the QFTest MCP tools we already had, but now I want to use something else. So what I did, I provided some procedures beforehand, like this procedure, which can move a piece from one tile to another. Let's just have a look how it goes. It uses, yeah, so it can move chess pieces. And also this procedure, which is a little bit more complex, which is sending an API call to a chess program and will get a move back to use. So let's reset the board basically to have a valid board state and call this procedure and see what happens if I call this procedure. So it's sending a web request and it's receiving a best move back. So this calculated move, the move I should make next is E2, E4 basically. And what I want to do is I want to make these procedures MCP tools. So to do this, I need to create I don't need to, but I want to create a new file. And I'm taking all of these procedures I've made here, and I'm putting it in this file. So next thing is I'm going to insert a package. By the way, this is the command palette, a very neat little feature we introduced in version 11. You can open it by Control, Shift, and F, and it's shortcuts to find basically everything in QFTest you need. So what I'm going to do is I'm going to insert a package, and we have a look at the standard library tools. I need this annotation to make sure that QFTest will recognize that whatever I put in this package is a tool. Next, I'm going to move everything that's not a helper procedure into this package. And this is also required for my procedure. I forgot it in the German demonstration, so I'm going to do it now before we get an error. Okay, I'm going to name this package, well, tools to make, I'm not very creative. So now these are already recognized as MCP tools. Basically, they will be recognized as MCP tools soon. But yeah, I have to provide a comment, a description for them. So let me just do this. Move a chess piece from a specific tile to another tile. So this is the description. So the MCP, the agent knows what to do. I have to specify which params are needed. There's the param from. So that's the tile the piece is moved from. Let me copy this because the parameter 2 is of course very similar to 2. And lastly, I'm going to provide a user-specific name. I'm going to name this move chess piece. Yeah, why not? Move chess piece. That's a good name. And as for the other procedures, I'm going to simply copy what I prepared. So you don't have to watch me typing for about 5 minutes. I'm also going to provide a start MCP tool. All right. Okay. Next thing to do is to save this. Let's call it chess MCP English. MCP. There we go. Typing during a live demonstration is always a pleasure. And now I'm going to tell QFTest that this contains MCP procedures. So the best thing to do probably is to simply copy the file path via right-click context menu, then go to the options and then simply enter this. And all right, now basically that's all I had to do. And now these 3 procedures should be available and usable by our AI agent. So let's get back to this test suite and let him calculate and make a chess move. And we are waiting with great excitement. The thing I want to show you is the protocol, of course. So I'll have to wait. But as you can already see in the terminal, he calculated a move. And because he had an output in the terminal, it's very likely that he used our procedure we just provided. And he also moved the piece with ease. It didn't use drag and drop this time because clicking is enough. And yeah, he's done. So let's have a look. What happened? We go to the tool uses. He got a snapshot, but now he used calculate next chess move and move chess piece, which are the procedures I provided to him. So this is a simple way to make procedures which the AI can use to interact with your program. And to demonstrate that this is not exclusive to use within QFTest, I'm going to start my Claude and do the same thing from right here. So what I did is I already connected the QFTest MCP server to Claude, which is very easy to do. You can find out how in the manual, like right here. Simply need to put a little command in the Claude desktop in the config JSON, which I already did. So let's have a look at our connected MCP servers. And the QFTest MCP server is connected, and it has 42 tools available. Let's have a look at them. So as you can see, there's a standard tools available, which is not a surprise, like get client screenshot, which you can find right here. But there are also other tools available, like our move chess piece or our calculate next chess move procedure. If we have a look at this, for example, you can see that the description I provided within QFTest is available for this AI agent. And well, this tool is available, so let's see it in action. I made my move. Let's start with this. Let's play chess. I made my move. It's your turn to make your move. And to make sure he uses our tools, I'm just going to say, use the QFTest, the QFS MCP tools. This is, again, probably not needed, but this is a demonstration, and I want to make really sure that he does what I want him to do. So he's loading the chess-related MCP tools. As you can see, he's calling our MCP server, which we connected. And my hands are off the mouse. He's calculating his move with our tools. He's making his move according to, well, the procedures we defined. And yeah, as you can see, he's calling our QFTest MCP server to make his moves, and we've done it. We've defined our own MCP tools and called them from outside of QFTest. To demonstrate how easy this is, I'm going to switch to a different application. Also simply a different application type, probably. So let's go to the sample test suite. And I'm going to demonstrate it again on a Windows application. Let's start this. This is the Windows calculator, which is not a web application or a Swing application. Just want to demonstrate what we can control. And there it is. should be connected to our QF test soon. Not yet for some reason. It's always great, live demonstrations. But yeah, probably because I was a little bit too quick before he could connect. So let's stop right here. See, is he connected? He's not connected yet. So only the German calculator is working. I remember. Okay. Only the German calculator is working. So, do you want to make these changes? Yes. No. Just a second. I'm simply going to switch to the German QF test and start the German calculator. Probably could have done so differently, but yeah, this is how I did it in the German demonstration, and it worked. So, okay. So let's have a look. This is the same QF test. It's the same, the same test suites we've opened before. But let's just have a look at the Windows 10 calculator suite. All right. Okay, and what I want to do now is I want to create another MCP tool. And I want to make it very simple. So I'm going to use the recording function. And the MCP tool I want to define is simply the tool to add two numbers with this calculator. So 8 plus 5 equals 13. Let's record a check. And yeah, change this check into a fetch text. So we get a result, and this is the result we get from the procedure. So we can pack this thing into a procedure, which we simply call add two numbers with calculator. And as parameters, we of course need two numbers, number 1 and number 2. And they should be used. So we simply don't always press on 8 and things. We are going to replace this in the ID. So number 2, let's have a press number 2. And then we'll add a return, and it should return the variable sum, which we fetch right here. So we've made a short procedure, and now this should be an MCP tool. We want to make an MCP tool out of this. So what we do is we simply drag it into our tools package, which is annotated with MCP tools, and we provide a good description. And of course, I prepared this description, so I don't have to type it in. Uses the Windows calculator to add two single-digit numbers. This is all I needed to do. No. And I've provided a specific name, MCP, add numbers with calc. So let's go back. Let's have a look in our Claude if it worked. So we reconnect to the QF test MCP server just to be sure. And as you can see, we have 43 tools available. And if we look at the tools, you can see add two numbers with calculator was successfully added. It is now available for our Claude. And now I can say, please add 8 and 2 using the Windows calculator. Okay, let's hope he uses our tool. It appears he does. So yeah, you may use this tool. That's okay. Okay, and well, he did. I wasn't the one who clicked at light speed on these points. So yeah, that was the demonstration for the MCP tools. And one last thing, which is probably very, very interesting, is that you don't have to open your QF test to do these things. What you can do is simply start it in batch mode. So what I'm doing is I'm going to start the MCP server in batch mode, and just minus MCP is enough, but I'm going to provide the port just in case, you never know. And this was all I had to do. Oops, this was not what I meant to do. Let's get back into Claude. As you can see, I don't have any QF test open, but if I enter the MCP command, you can see the QF test MCP is available. So yeah, this is our batch mode QF test MCP. And if I have a look at the tools, you can see the calculator tool is available, our chess tools are available, and of course, I can simply play a game of chess with Claude. Let's play a game of chess. You are white, and use the QF test MCP tools. Make your first move. And since I provided a start tool, he should be able to start my chessboard. As you can see, he's trying to start the chess app and calculating the first move. So he's calling our MCP server. Any second now. There we go. And he started the chessboard. Again, it's not me doing this. My hands are off the mouse, off the keyboard. And well, he will use our tools to calculate his move, to make his move right there. And now, if I want, I can play a game of chess against Claude, which I will not be doing, I think. But I think I made my point. Yeah. And well, there you go. You can use QF test to control basically any application that we can already control. To have, you can use it as an MCP server to let AI control your applications if you want to. And yeah, this is what I wanted to show. Also, a quick cheat sheet if you want to take a screenshot, but we will also upload this presentation. These are some annotations you can use in your descriptions and yeah, to provide the MCP tools. All right. As a conclusion, we provided some powerful, new, exciting tools for you to use in your tests, like the test generation or the instruction node. But we also gave you basically everything you want to create your own MCP server, your own MCP toolkit for your application. You can use QF test as a bridge between the AI and your application and make it, well, fully controllable by AI. And I think this was everything I wanted to demonstrate. So thank you very much for your attention. And I think we can move on to the Q&A section. So.
Brilliant. Thank you, Daniel. As I said in the beginning, the QA part will not be part of the recording, so it will not be on YouTube later. It's exclusive for everybody who's here right now. So thanks to everybody for watching and attending, and we'll see you next time in our next special webinar, which will be really relevant to this whole topic, because next month there will be another webinar about QF Test 11, this time about the new procedure call recording feature, which is a really interesting new method where you can do a recording in your application, and it will and QFTest will automatically insert procedure calls from your library or from our library instead of plain nodes. If that's interesting to you, head over to qftest.com, to our website, and sign up now. This will be on September 14th.